Okay, here's number 16 from the study guide. A biker is in a race. She starts from rest and accelerates at 0.015 meters per second squared. Upon reaching a velocity of 22 meters per second, she stops accelerating. She maintains that same velocity of 22 meters per second over the next 6,530 meters. At that point, she crosses the finish line, still going at that same velocity, and we have to find her average speed over the entire trip. Now, the thing we first notice, she accelerates, right? She starts from rest. That means the initial velocity is 0. She's not moving at the beginning. The acceleration is 0.015 meters per second squared. And then she stops accelerating. The end of the acceleration, the final, is when she reaches 22 meters per second. Now, the first question to ask yourself, when she stops accelerating, when her acceleration is finished, is the trip over? The answer is no. So this is some first segment. What happens after the first segment? In segment B, she has a constant velocity of 22. She maintains the same velocity. So the next question to think about, can we use the same equations for A that we would use in B? Are the two segments really just one big segment linked together, or is there something dividing the two up? First, to answer that question, we have to realize segment A is where we have constant acceleration. How do I know? Because they told me the single acceleration value. That is her constant acceleration value. It doesn't ever change. Segment B is constant velocity. And that makes all the difference. And how do I know it's constant velocity? Because they say she maintains this single velocity for the rest of the trip. And let me go ahead and put down that her displacement there is 6,530. So I cannot use the same equations. I've written some equations down. This one is for constant velocity. I would use it for segment B. And these four are for constant acceleration. So I cannot use the same equations in the two segments. I have to use different equations. Okay? Okay, now that we've got that sorted out, the question becomes, what are we trying to solve for? What's the unknown, and how do we get there, right? Let me read the last part of the question. What is the biker's average speed over the entire race? Well, I know the equation for average speed is distance over time, but I also know that when there are segments, you have to add the total distance and divide by the total time. So now we ask, which distances do we know? Do we know the distance from A? Doesn't look like it. That was not given. So we will need to calculate that first. Do we know the distance traveled in B? Yes. If the displacement is positive 6,530, then that means the distance is the exact same value. Just take out the sign. Okay? That's one thing that I know. So this I have to find. This I already know. Do I know the time in segment A? Nope, it's not listed. I better find that. Do I know the time in B? No, that is also not listed. So let's start by finding the distance in segment A. I look to my equations for A, the equations of constant acceleration. None of them have distance, but if I find displacement, I could simply drop the sign, and now that will be my distance. So which equation can I use to find displacement? Well, remember that we know velocity initial, velocity final, acceleration, and we're looking for delta x. So let me see. Velocity initial, velocity final, we know acceleration. Here's the equation with one unknown. Let me write that down and use that. Velocity final is 22. Velocity initial is 0. The acceleration is 0.015. And the delta x is my unknown, so I don't plug anything in there. I have to divide. This is all going to go away. I have to divide both sides by the product of 2 and 0.015. And when I do that, let's get our answer over 2, and I'm also going to divide that by 0.015, and I get 16,133. .33 repeating meters. So how do I turn that into a distance? I just drop the sign, but it's already positive, so it's the same exact answer. Okay, that's distance 1, or distance A I should call it. Now I know this value. Let's find the time from segment A next. Remember, segment A is constant acceleration. Let me move this. Oh. Move this over here. The time from segment A is my next unknown. And this is constant acceleration still, segment A. So I'm sticking with the same equations that I was just using. Now, if I'm looking for time, let's see, I know the acceleration, I know VI and VF, so I'll solve for time using this equation. There it is. My acceleration is 0.015. My final velocity is 22. I could subtract 0, but I'll just get 22, and I'm dividing by time. Careful now, don't divide by 22. Why not? Well, yeah, you'll cancel out the 22s, but time is in the denominator. We need it in the numerator when we solve. So to solve for time, we have to first move it over to the numerator, which is kind of like cross-multiplying, right? And then we'll have 0.015 times t equals 22. So next we'll divide both sides by 0.015. And the time interval for segment A comes to 1466. 0.6 repeating seconds. Okay, wonderful. We're getting close. We know the time from segment A. We know the distance from segment A. What's next? Let me look at my speed equation. I know time in A. Now let's find the time in segment B. Okay, what do I know in B? Well, the first thing I remember is I have constant velocity in B, so I need to use that top equation. It's the only equation that I can use. So there's no decision here to make at all. I'm looking for time. I know how far we went, I know the displacement, and I know the speed, the constant velocity. So this is 22, positive 22 meters per second is the constant velocity. The displacement is positive 6530. And time is right here. Again, we're going to have to multiply both sides by time, which is going to move it over to the numerator. And then this 22 will have to get to the other side away from time. So because it's in the numerator, we'll divide both sides by 22. It will end up with time is 6530 over 22. That's, hang on. 296 and then 8.81 repeating. Seconds. Okay. That's the time for segment B, is what I've just found. Let me just put this here. Equals. Okay. I'm finally ready to move on. I can use this equation. The average speed over the entire trip is A's distance. That's what I found. 16,133, ... plus B's distance. That's 6,530. I divide by A's time for segment A. 1466, ... Keep all those decimals. I add with that first time, I add the second time to get the total time. And when I plug all this in, I think it's 12.8 is my recollection. And if you look at your sig figs, it rounds to 13. Lucky number. Thanks for watching.